Hi guys, so today we're going to be starting the topic of similar shapes, and this is going to be the last topic that we have to do for geometry. And as always, I'm going to leave the link to the notes in the description so you can access them there. But for now, I just wanted to understand the concept. Now, for similar shapes, what is the meaning of similar shapes basically? First, we're going to have to know, in general, two shapes are similar when all, or let me say I should write it like this so we can understand this better. When all angles are same and proportion of sides is same. Okay, now this is general. Okay, this is in general that all angles have to be the same in both of them. Okay, so for example, if I take a square, for example, so let's take these two, not a square, but let's try to make them into a square. Let's give them a bit of a, okay, let's make it a bit bigger as well so we can understand this. Okay, and same thing here. Now we have two shapes, and let's make the shape a bit smaller to understand this. Let's say we have a bigger shape and you have a smaller shape. Okay, now let's say in this shape you had this angle as 90. Okay, this angle as 90. Okay, that's a square, it will have all of its angle as 90, and this one is also 90. Okay, so first thing, all angles are same. So this is 90, this one is 90, this one is 90, and this one is 90. This one is 90, this one is 90, and this one is 90. Okay, second step, proportion of side. Well, now what does that mean? For example, this side is, let's say, 6, and all these are 6 because in the square all of them have to be the same. Okay, then this one is 12, 12, 12, 12. What does that mean? What that basically means is that if I have 6, the proportion, meaning this is what 12 is, 6 times 2. Times 2. If one of the sides is times 2, every other side will be times 2. So 6 times 2 is 12, 6 times 2 is 12. Okay, 6 times 2 is 12. So all of them will be the same. And this is just an example of a square. We can also take a rectangle, or you could say, but a triangle. A triangle has some different rules to it. We're gonna get to that in a second. And yeah, one thing to remember, that for generally, okay, in two shapes, these two conditions have to be applied. Both of these must be present for shape to be similar. So it cannot be that if one of them is same, that they're similar. No, well, both of them have to be the same, meaning both of them have to be true, both conditions. Let me also fix that here. Both conditions have to be true. Well, one of them have to be, if one of them is false, then you cannot say that those are similar. Okay, the next thing we have is our triangle. Now there are 3 conditions. Okay, 3 conditions for a triangle to be a similar shape. Now there are 3 conditions of a triangle, for 2 triangles, for 2 triangles to be, okay. Now what are those 3? First one is gonna be that all the angles match up. So it's gonna be the same. All angles must be same in both shapes. in both triangles, so we don't we could say go to different shapes, just in triangles. These rules are only for triangles, okay? Then second rule that we have is that all the three sides are proportional. Okay, so up till now the two general rules apply here, okay? We could say proportion of sides has to be the same. Proportion of sides has to, okay. Then the third one, this is going to be the different one, that any two sides, if any two sides are proportional and the angle between them is the same. Okay, but I'm going to understand this with an example as well. If we take any two sides that are proportional then angle between them should be same. Okay, we have our three conditions. Let's understand it from an example. And one thing to keep in mind here is that it is not necessary that all of these have to be true. Okay, if any one of them is true, then like there's two triangles are similar. If any one of the conditions for a triangle is true, then they are similar. Okay, now we have a question in front of us where they have given us two triangles and they're saying show that these two triangles are similar. We're going to check our conditions. For the triangles we had all angles must be same. Okay, let's see if they're same. 94, okay. 94, no. So angles are not same. Aren't same. Second condition, which was proportion of sides has to be same. Okay, this is 6. Okay, let's mark it here 6. This one is 3. Okay, 6 and 3. I think I'm dividing by 2. Okay, let's check the other ones. It should be the same. 4 and 2. I'm dividing by 2 again. And then 10 and 5. I'm also dividing by 2. So proportion is same. So we're going to say they are similar because we're going to prove this. Proportion is same. Let's give them an example. For example, let's say this was A and this was B. This is let's say C. This is D. We're gonna say okay, AB is 2 times, sorry, not AB is equal to 2 times CD. Now let's look at one final question, a long question basically, but let's see. The question is long, the answer is not that long. John is swimming in the sea when he is at point B. Okay, he is 20 meters away from a rock that is 8 meters tall. Okay, so John is here, over here. Let me also mark it here. John is here. 20 meters away from John is a rock that is 8 meters tall. So John is here, 20 meters go here, and 8 meters up here. Okay, then there's a lighthouse 50 meters away from John. So John is here, away here. We have a lighthouse. Okay, that is directly behind the rock. From his perspective, the top of the lighthouse is in line with the top of the rock. Okay, that means, let's say if you're John and you're seeing the rock, you are seeing that this and this are in line because this one is closer to you, but that one's a bit far to you. That one's actually, this one is taller, but this one is closer, that's why it seems in line with it. The top of the lighthouse is in line with the top of the rock. How tall is the lighthouse? Now, what's this got to do with similarity? For similarity, we're gonna have to use the concept to find out the height of the lighthouse. Okay, first thing, we can see I have two types of triangles right now. One triangle I have is here, from John to the rock, okay? I have one here, and that means I'm gonna have one angle here, okay? This is gonna be my angle. Second triangle is from John to here, okay? I think I can mark that as well. Let me go here. So look, from here to here to here. This is one big triangle, okay? Let me undo that. From here to here, we have one big triangle, okay? And from here to here, we have one small triangle. If I take this side and this side of the big triangle, I'm gonna have the same angle. If I take this side and this side of the small triangle, I'm gonna have the same angle. So I have the same angle right now. I have the same angle right now. That means that these two are similar. If they are similar, what I'm gonna do is I'm gonna first find out what's the proportion of these to find out the actual height of the lighthouse. To do that, what we're gonna do is, first, we're gonna see, okay, 20 meters away, I had 8 meters. 50 meters away, what am I gonna have? What does that mean? Look, let me mark that here. Let's say after 20 meters going front, the height was 8 meters. Let me actually mark it like this: length to height. The length is 20 meters and then the height is 8 meters. If the length is 50 meters, what is the height? Mark it X. Then next step is what we're going to do is we're going to make a cross. Okay, this might be a new method. This is called cross multiplication. What you do here is, normally you first make a cross in the middle, and then 50 times 8, that's going to give you, I think, 400 meters, okay, equal to 20 times x, that is 20x. Then 20 goes on the other side, or you could say divide by 20 on both sides, okay, divide by 20 on both sides. That's going to leave you with 400 over 20 equals x. 20 times 1, 20 times 20 is that. So x is 20 meters. So the lighthouse is 20 meters tall. And that's it. We just had to write these 3 lines, but the question was very long. Okay, that's it for today's class. And as always, the link to the notes are in the description. You can contact me, and I'm also going to be hosting, as I said before, a full month Pastpaper session in the month of April. So anyone who wants to enroll there can contact me through my WhatsApp number. I'm going to leave in the description. And yeah. And if anyone wants to book a free call with me to discuss issues in maths, I'm also available for that. I'm going to leave my number in the description. Contact me and let's figure out your issues. Thank you.